discuss A/B testing. So, A/B testing is a method used to compare two versions of digital assets, either web page, email, features, etc., to determine which performs better. It is a cornerstone for data-driven decision making. It allows the organization to validate changes through controlled experiments. The purpose of A/B testing is to minimize the guesswork in product development, ensuring that improvements are backed by quantitative evidence. For example, testing a new button color on a web page to measure its impact on click-through rates. And however, if we talk about data engineers play a critical role by setting up reliable data pipelines, ensuring experiment tracking, storing clean data, enabling scalable analysis framework. Without this foundation, even well-designed experiment can yield misleading results. And in terms of if we talk about core concepts of A/B testing, so the control, so there is control group versus variant, where the control group receives original experience while variant group experiences the new change. And if in terms of hypothesis formulation, experiment starts by hypothesis. For example, changing the button color to green that increase clicks by 5%. As an example, then is the statistical significance and p-values, where these help determine whether the observed effect is really real or just due to the change. Then is confidence intervals. That indicates the reliability of an estimate such as conversion rate, uplift, and then is type 1 and type 2 error. So type 1 is a false positive while type 2 is a false negative. Both can mislead the result though. And in terms of A/B testing workflow for data engineers, so normally we go through the test design where we random sampling which ensures the unbiased distribution of users across the variants, and then is data pipeline setup, either ETL or ELT processes extract and transform logs into usable datasets, and then is logging and tracking. So events such as like clicks, views, purchases are logged using systems like segments or snowflow. And then it's data schema, which is standardizing the events formats in terms of JSON, Avro, that simplifies the analysis. And so if we talk about infrastructure and tooling, so in terms of they're like off-shelf tools where platforms like Google provide A/B frameworks with UI support, and they're like custom platforms which are built in house for scalability and privacy concerns. And then is real time versus batch, where real time processing using Kafka, Spark streaming, which offers faster insight, and batch, whereas Airflow or Snowflake is a cost effective method. Then is engineering stack, uh, where the Airflow for the orchestration and Kafka is for the ingestion and dbt is for the transformation. And moving forward to data collection and storage. So it's it starts with the event schemas which define what data to collect and their structure. And then is most important data quality, which ensures the completeness and correctness through the validation and the monitoring. And then is storage options. So we have data lakes like S3 and warehouses like Snowflake, Redshift, and in the last there is optimization process in which partitioning and indexing that improves the query performance. And in terms of uh, terms of analysis and reporting, we have SQL queries, which is used to segment users, calculate conversion, compare metrics, and then as uplift, where the percentage increase from control to the variant, and then by Bayesian and frequentist. These are different approach that are used to calculate confidence in the results. Then is multi-test handling, in which we use the experiment ID and time boundaries to avoid the overlapping influence. And moving forward, dealing with challenges, so we have simple ratio mismatch, which indicates a bug in randomization, and then it's bot traffic, which distort user behavior data, and there might be a leakage where users are exposed to both variants, and then a seasonality where day of week effects may, which bias the result, and then as delayed effects. So some metrics like retention that uh, need time to manifest. And in terms of the ethics and bias in the A/B testing. So ethics, so users should not be harmed or misled, and the biases can creep in via sampling, time windows, or data filters. And then is fairness, where segment-based fairness ensures change benefit all groups equally, equitably, I will say. And that is in terms of the real world case studies. So we have e-commerce where they test pricing, page layout, check checkout flow, and then is streaming where testing recommendation algorithms or thumbnail images are made. Then is mobile apps where testing notification timing in terms of app UI changes. And then there are certain best practices and the frameworks. So in terms of the governance, there are track, test designs, owners, outcomes. Then is life cycle management, where test should have been defined start and the end point, and document all the learnings it goes through. And then they have the automation, where helps scales the experimentation and reduces the human error. And in terms of the future of A/B testing and data engineering role, so they are like multi-armed bandits, so dynamically shift traffic to better performing variants. Then it's personalization, where tailoring experiments to the user segments. Then is real-time loops, which enables faster learning and iterations. And in the end, uh, conclusion, the A/B testing empowers the organizations or engineers to optimize the experience using evidence-based decisions, and data engineers enable trustworthy insights by managing data pipelines, ensuring data quality, supporting scalable systems. And as the experimentation grows more sophisticatedly, so data engineers role empowering intelligent systems. Thank you for watching.